This problem says an electron and a proton, each starting from rest, are accelerated by the same uniform electric field of 200 newtons per coulomb. Determine the distance and time for each particle to acquire a kinetic energy of 3.2 times 10 minus 16 joules. Okay, so the work done by the electric field is equal to, and the electric field is constant, is equal to change in kinetic energy. They initially start off from rest, so this is 0. And so that's the final kinetic energy is given. And the work done is the force times the distance, which is Q times the electric field times the distance, should equal the kinetic energy. And so the distance they travel is kinetic energy divided by QE. And the charge is the same. Q is the same for the proton and okay, so the distance traveled, the kinetic energy is the same. Okay, so distance will be the same. So distance over which the proton and electron gain the final kinetic energy is the same. Okay. And that distance is the final kinetic energy is 3.2 into 10 minus 16 joules divided by the charge of the proton and the electron is that, and 200 newtons per coulomb. And this will work out in meters, so this is 2,200 divided by 1.6 into 10 meters. Okay. Now the proton being heavier, it will accelerate to slower, and it will take a longer time to cover this distance, 10 meters. Okay. So now we'll find the time. Okay. So let's add a page. So force is mass times acceleration. Acceleration is force over mass. Force is Q times E. So again, the force is the same, except that the mass is different, so the acceleration will be different. And x minus x naught equal to d equal to v naught t plus 1/2 at squared. So they start off at rest, so d equal to 1/2 at squared. 1/2 QE divided by the mass t squared. Okay. So the time is 2md over QE to the power half. Okay. So there we go. Now the mass of the proton is about 2,000 times greater than that of the electron. So the time taken by the proton will be greater. Heavier the particle, greater the time it takes to cover that distance. Okay, which makes sense. So now we'll calculate the time for the proton. and I'll let you guys calculate the time for the electron. The mass of the proton is 6-7 times 1.67 times 10 to the minus 27 kgs, and D is 10 meters divided by Q. The charge of the proton is 1.6 into 10 minus 19 coulombs, and the electric field is 200 Newton per coulomb, and whole thing to the power half. Okay, so this is this works out to, okay, let's take care of powers of 10. That's 10 to the 27, 10, this comes to the top, that becomes 10 to the minus 8, 10 to the minus 10, okay, so we'll say 10 minus 5, so 2 into 1.67 into 10 divided by 1.6 into 2 to the power half, and then 10 minus 5 seconds. And so this becomes, this is equal to 3.23 into 10 minus 5 seconds, which is 32.3 into 10 minus 6 seconds, 32.3 microseconds. That's the time the proton takes, and the electron, of course, being lighter, will take less time. Okay, I'll let you guys calculate that, or if you want, I'll. So here's a so the time of the electron will be the time of the proton divided by the square root of mass of the proton times mass of the electron to the power half. You can check this out, and so you can verify this 32.3 microseconds, and the mass of the electron is 9.11 times 10 minus 31 kg. Mass of the proton is 1.67 times 10 minus 27 kg to the power half. And so this is 33 microseconds. That's the time for the proton, and this factor works out to that's 4 9.11 divided by 1.67 to the power 0.5 2.34 into 10 minus 2. Okay, so which is 0.8234 into 32.3 microseconds. So the electron takes 2%, 2.34% the time that proton takes. Okay, that finishes that problem.